And that's this here. So people probably heard of getting a lumbar puncture, epidural, another example of how this would be done. So this is basically just a procedure in which you take a needle and you inject it in between the vertebrae and you go into the actual epidural space. So you actually puncture through the dura mater, epidural sheath, the dura mater. And that's actually what this is showing you right here. Now you can do this to pull out some of the cerebral spinal fluid to check for infections. You can actually try to grow bacteria. If you grow bacteria, then you know those are bacteria that are inside the spinal column. Or two, you can actually inject things like, yeah, you can. That's cortisone's not injected there. I'm trying to think about paralytics and anesthesia. Thank you. Yeah, anesthetics. So, for example, if you're going to go into labor and you want to get an epidural, right? They'll inject a needle into your epidural space and have a constant supply of anesthetic to keep you from feeling the pain, right? That's how that works. Now, the trick to this, of course, is making sure you poke in the right spot. And how do you know where the right spot is? Well, as I said before, the spinal column ends at right around L1, maybe L2, but usually L1 for most people. So you want to poke lower than L3. How do you know? Well, an anesthesiologist will lean you over like this, right? And count.
In the middle of a contraction.
While you're in the middle of a contraction, not conscious, right? And you feel that bump on the back of your neck, that bump is C7. So they lean you over, they start at C7, and they count down, and they find the right spot, usually in the neighborhood of L5 to L, probably around L5. I think that's what they're showing you here, yeah. And they'll inject the needle in the vertebrae, and that's how they'll inject the anesthetic. It can only be done by anesthesiologists because they're the only ones who are basically certified to do this, because obviously it's a very bad thing if you poke the wrong spot, obviously. So that's what this is. So, sorry I missed it, I just forgot. This picture will be on your exam, big surprise. One, because it shows you some of the nice things I've already talked about. Right here, you see the posterior root ganglion, or as I said, the dorsal root ganglion. You see the roots, you see the posterior roots, you see the anterior roots, and you see a nice big spinal nerve. It's a nice thing to really show you there. But really, it shows you a big picture right here of what an actual nerve looks like. So when people say nerve, you should think, oh, a big collection of axons, because that's what this is. So just like in your house, you have wires like, maybe you ever open up a phone line wire? It has 5 or 7, depending on the type of wire, little wires inside of it. So that's a bundle of other wires. Well, that's what this is too. It's a bundle of many different fibers, or many axons. And it's actually very similar in composition to what you see muscles being built as well. So the terms are similar. They're not the same, but they're similar. So I'll show you what I mean. So here, we have a bundle of sticks, or a bundle of fibers, and we call it a fascicle. Just like we did with the muscle, a bundle of axons in a nerve is called a fascicle. We also have membranes. And we have a membrane that surrounds the entire nerve. We have membranes that surround the fascicles. You can see right here these membranes. And then you have a membrane that's actually surrounding individual axons. So right here in white is the myelin, but right outside of that, just superficial to that, you can see a membrane. Now these membranes have the same prefix as we saw before with muscles. We have epi, peri, and endo. But instead of mycium, it's now neurium. Neurium. So epineurium is the membrane here. Perineurium is the membrane that surrounds the fascicles. And then endoneurium is the membrane that surrounds each and every fiber or axon within that nerve. 4 or 5 terms that can easily pop up in your exam. Definitely a picture you will see again. Greater detail about the ganglions. As I said before, a ganglion is a bundle of soma that's in the peripheral nervous system. So this is the ganglion that you see right here, and you can see where it actually exists. This is to show you a bigger picture. And of course, this is involved in sensory information, as we talked about before, and I'll mention again, sensation right here. Those are those individual somas, those individual cells that pick up the sensory information. Now, as I said, if you think about nerves, and particularly the nerves that are here, this nerve that exists right here, this spinal nerve, has fibers that are ascending and fibers that are descending. Fibers that are going toward the control center for sensation, and fibers that are going toward effectors for motor control. Right? So this is mixed. Mixed. Every spinal nerve, all 31, are mixed. Okay? Meaning there's some sensory fibers and some motor fibers. That is not true when we get to cranial nerves later on. We have 12 cranial nerves, and some of them are mixed, but some of them are just sensory and some of them are just motor. I will never have you remember that, as far as which ones are sensory, which ones are motor. But there's a very nice saying that'll help you if you ever have to for a class. I put it in the next lecture notes. But I'm just giving you a heads up now that there are some nerves that are devoted toward one function. But every one of the spinal nerves are mixed. So as I said, we have 12 cranial nerves, and you'll learn those next week, but we have 31 spinal nerves. How are we going to name those? Well, the great thing is we already learned the bones, and so that helps you the best. So if you know the bones, which you should by now, this should be very simple for you to understand how to name these. Now, the only trick here is to remember that on the first vertebrae, we have a pair of spinal nerves that are just superior to it and just inferior to it. So we have 2 around that first vertebrae, and then underneath each and every other one, we have 1. So what I mean by that is we have 7 vertebrae that make up the cervical vertebrae, right? 7. So remember that, right? But when it comes to the spinal nerves, we have 8 spinal nerves in the cervical region. Because one's on top and one's on the bottom of that first one. Okay, so there's 8. That's the only trick in all of this. Just remember that first one is 8. Okay? After that, we have 12 thoracic nerves. 12, that's when we eat our lunches at noon. Right? We have 5 lumbar nerves because we eat dinner at 5, just like we learned the bones. And then we have 5 sacral, because I don't know if you remember this, but there's S1 to S5, even though we talked about just 1 sacrum. Okay? And then 1 coxial, coccyx. You just call it 1. Now, how do we name these? Well, it's named the same way. C1 to C8, C1 to C8, T1 to T12, L1 to L5, S1 to S5, and then the bottom one here is just called C0 for coccyx. C0. Never asked you that, I'm sure. I don't see how I could ask you that, but just so you're aware, that's how it's done. Okay? So we'll talk about different nerves or spinal nerves being damaged or transected certain areas of the cord, which means cut. And these particular spinal nerves are affected. They'll name it according to that. T12, right? T7, T6, L5. It's not the vertebrae they're talking about. It's the spinal nerves they're talking about. Let's stick on this picture. I mentioned it before, and here's where I definitely want you to remember this. Bottom of page 9. Okay? Again, the branches that come off the cord. We'll stick with this picture right here. These right here, the rootlets, the root, and then the spinal nerve are all in the peripheral nervous system. Right? We talked about that. They're not actually part of the cord in that sense. They're actually part of the peripheral nervous system. The fibers that are here are ascending or involved in sensory perception. The ones that are here are involved in motor control. right, or to go toward the effectors. So you should be able to describe that to me, and I say that here. So the anterior root, or the ventral root, okay, are involved in motor signals. So the ones in front here are involved in motor signals, right? They're going to go to muscles or other effector organs like glands to cause some sort of effect. And so you can imagine the descending pathways that we talked about before, right? The first, the descending pathways that go down the cord are going to go down that passageway, right? They're going to go down here and come out this way towards muscles. That's the pathway they're going to go down. Okay? Sort of the lower motor neuron is what we're talking about. And then the opposite is here. These are involved in sensory perception, right? So the posterior, or what I always call the dorsal root, well, I think of the ventral root is sensory. The dorsal root is sensory, sorry, the ventral root is motor. So the dorsal root is involved in sensory perception. Or the posterior root is in sensory perception. And that's where we have the posterior root ganglion, or dorsal root ganglion. Okay. So I underline that because I think that's an important thing to be familiar with. I've said it 3 or 4 times, so I think we're good there. You may have questions about that? Yeah.
Are these pictures that are in the laboratory?
No, wait. Which ones? This one could be. This one could be. I'm not saying it will, but it could be. I mean, a lot of the same pictures can be used to show this general idea. So I could ask you what this is right here, right? Not this here, but what this is actually here. So this would be considered the ventral root. This would be considered the dorsal root. Okay? Or this is a dorsal root ganglion. I could use this picture for this. I could. This here, I could too. Say, what's this entire thing right here? Or you see it here as well. I could. But this will not be. This level of detail will not be on your lab exam. Okay? So this is actually something that I didn't always teach, and then I found out later on that I probably should, because it's the only kind of time you're ever going to get exposed to this. So I've added it in over the years. But I'm going to keep it simple for you guys so you understand. So you would think, okay, that once the spinal nerves come off, that they're just simply going to go to whatever parts of the body they need to go to. Well, then that would mean that there are 31, or really 62, because there's 31 on each side, strands or nerves going through our body. But that's not true at all. There's hundreds of thousands of different nerves that are named in our body. And I'm not going to have you memorize any of them at all. Okay? Go for your MD, memorize them all. Go for my class, memorize nothing. How's that? Okay? But I will show you what happens. And so what you're going to see in just a few minutes is, okay, well, we're going to have some fibers from one spinal nerve mixing with some fibers from another spinal nerve. And then yet from some other and some others. And so in general, we're going to end up building our, we call nerves, from several different spinal nerves. It's going to be a bigger collection. You're going to see how that works in just a few minutes. Okay? But let's first look at this. Let's look at this. So right here, all we've talked about so far is all of this. We haven't talked about this stuff right out here, all these little yellow lines. None of that. We've stopped right here. So we've talked about the 2 roots and the root ganglion. But if you notice, just right here, just as the spinal nerve exits the bony area, right, it splits. It splits. And it splits in such a way that it makes a lot of sense, okay? Some of the fibers are going to go on right here, in what they call the anterior ramus. The majority of fibers, in fact. When I say fibers, I mean axons, okay? The majority of fibers are going to go this way. And they're going to serve whatever part of the body that spinal nerve serves. So it may be the arms, the legs, whatever the case may be. It's going to serve those general areas, okay? So that's what we call the anterior ramus. Posterior ramus are going to go toward the posterior side. So like, what do I mean? Well, so imagine we have, again, this is our body, right? This is the anterior, this is the posterior. So you've got an idea now. This is the front of the person, this is the back of the person. There's your spinous process, okay? Now, these fibers are going to primarily, the anterior ones, serve the anterior functions of the body. So that the anterior side. The posterior is going to go to the posterior side of the back. So your back muscles, for example, or your sensory perception on your back are going to be felt or controlled by fibers along the posterior ramus, whereas those on the front and the limbs, okay, are going to be controlled by these fibers on the anterior ramus. The last one, which they have it here, meningeal, yeah, right here. There's a small little branch called the meningeal branch that goes into the meninges because we have to have sensory and even some motor control within the actual spinal cord and brain. So that's what this is. Not really motor per se. Right? Not something I'm going to get in a lot of detail about at all, obviously. What I want to show you here is this, and I'll show you a better picture than that first. Okay. What I wanted you to clue in here, so you see you clue in real quickly as you can see. So here is C1, here is C2. Okay? So if you notice, this actual spinal nerve is called C1. But notice what happens. Almost immediately, once it goes outside the bone, some of the fibers come over here and mix up with some of them from C2. Really? Yeah. And then some of these fibers will come along and mix with C3. How's that? That's crazy. That's exactly what happens. There's a web-like organization where some of the fibers from different regions or different spinal nerves will come together and form certain nerves. So the nerves of our body, like the phrenic nerve, supraclavicular nerve, are all composed of different fibers from different spinal nerves. It's complicated. Okay? But in general, they perform a general region of the body. So again, some of these will become more sensory, some motor by how they split the nerve fibers up, but they still serve the neck and the regions around the neck and the arms. They just do so not as simple as C1, C2, C3 by themselves. There's a mixture. Okay? So they actually call these nerve plexuses or nerve plexes. Nerve plexes is what these are. And we have a couple of examples. So I'm just asking you to know what these are, and they're fairly simple to understand. Okay? So we have the cervical plexus. Well, guess what the cervical plexus does? Serves the cervical region, right? So we have the cervical, the C1 to C5, and you have basically the neck and muscles of the diaphragm are controlled here in the cervical plexus. The brachial plexus, which is here, guess what it serves? The arm. Okay? So again, C5, C6, C7, C8, and T1, which you don't need to know those specifically. Some of the fibers, you can see, will mix together, and then some of them will split apart and form other nerves. In the end, we have the ulnar nerve, the medial nerve, the radial nerve, the axillary nerve. All these nerves that we name over here are actually composed of fibers from various different cervical vertebrae and even one thoracic. So aren't you glad you're not a medical doctor? It's a little complicated here. Okay. But these are what the nerves we call in the arm, and that's basically where they come from. But they come from the general region that would serve that. They're not going to come from the lumbar region. That's going to serve the legs. It's going to come from the cervical region. That's what we call, in this case, the brachial plexus. By the way, in case you're curious, median nerve is the nerve that goes here. It's involved in the funny bone. It's called the funny bone. Whenever you hit that nerve. It's also the nerve that goes here in your wrist. And it's a common nerve when you have repeated actions of your wrist. If you do something that has a lot of repetition, or even service industry, if you're carrying trays like this, you can get inflammation in the tendon sheaths that are here. And that can cause compression on the median nerve and give you carpal tunnel. So that's what that's all about. Carpal tunnel is a small little passageway the median nerve has to travel through, and it's very easy for that area to get swollen and to compress that nerve and cause pain. That's what carpal tunnel is all about. The lumbar plexus, you can see here, again, L1 and L5 are involved in the feet, the legs, the thigh. Again, sensory and motor perception, so all the movements of the muscles and all the sensations of pain and everything else we talk about in our legs, even tickling your feet, right? Can be felt by or sensed by these particular nerves. Is there anything I want to mention specifically here? No, I got it. Well, yeah, let's mention the sciatic nerve. I don't see the label here. See here. Oh, it's coming from the I don't. Okay, that's one. So these are the ones, various different nerves that serve from L1 to L5. We call that the lumbar plexus, and the last one's called the sacral plexus, and the coccygioid plexus. And those are the ones here to show you. Again, this serves other portions of the legs, including the sciatic nerve, which I'll mention here. Again, this is just for fun. I wouldn't ask you anything specifically about it. But it's a common thing that happens, especially in women. And I'm not trying to be sexist, I'm just being truthful about this. The reason for that is because the women carry the babies before and after birth, right? Truth be told, it's true. And so what happens is, if you look, see the sciatic nerve that's right here is actually formed by different vertebrae right here in the lower lumbar region and the sacral region. Well, that's where all the weight bearing is done in pregnancy. And it's where all the weight bearing is done after pregnancy, lifting the baby in and out of the crib, especially if you have a big baby like my babies are all big. So that happens, right? And so you end up getting damage, and the right name here for what we talked about, the disc, right, gets ruptured. And when the disc gets ruptured, it's possible, not always, but possible, it'll push on the spinal cord in that region, and then that nerve will feel dullness or pain or lack of sensation. So you'll have, I don't know why it is, but it's usually in the right leg, not always, usually in the right leg, you'll feel numbness or pain. And it's more common in females than it is in males because of that, especially if you have babies. Okay. Talk about this quickly. Dermatome. It should be no surprise to you now, since you've seen how this is all built, that there's a lot of crossover, meaning that a particular part of your body, like if I'm touching myself here, or here, or here, it's not one spinal nerve that's picking that up. It's several different fibers that are going to different spinal nerves that are picking up that sensation. Does that make sense? And so that's what this is basically showing you here is, in general, which spinal nerves are picking up those general locations in the body. So in general, again, this region is picked up by L4. The spinal fibers are picked up here. If you tip your leg right here, you touch your leg. In general, it's picked up by L4. But there's actually some contribution by L3 and L5 as well. So it's not quite so concrete. But this is just a nice little map that just kind of shows you the contribution of those different nerves, from the cervical, thoracic, lumbar, and etc., that serve various parts of our body for sensation. Okay? Something simple. Somatic reflexes. We're going to be talking about reflexes. And I'm going to show you in general what reflexes are, and then I'm going to give you some examples, and you're going to be like, really, that's a reflex? And I'm going to be like, yeah, it's a reflex and you should know it. Okay? So that's where we're going. So I'll show you in general what a reflex is. This is what we call a reflex arc. And it's really what, when you think about a reflex, it makes a lot of sense. This is how we build. So what are reflexes? Well, you should know this. Quick, involuntary, stereotyped reactions. Quick, okay, that means fast. Involuntary means you can't stop it. Stereotyped. If something is stereotyped, it means it always happens the same way every single time. We call it stereotype, okay? It's automatic. Without our intent or awareness, we do it anyway, okay? It's without our awareness or our intent. So when something comes close to your eye, you're going to blink. Could you consciously maybe try to stop it? Maybe. Could you sneeze and keep your eyes open at the same time? Maybe. Try your eyes open, I'm going to sneeze. You might be able to pull it off. But the body's built differently. The body is built to have these stereotyped, involuntary, quick reactions called reflexes, and there's a reason for it. They obviously serve a purpose like keeping things out of your eye. So, reflexes require stimulation. Big surprise. They don't happen by themselves. Okay, there has to be some sort of stimulus. And so we have a receptor. Very general here. We have some sort of receptor. Let's say that we have a receptor for some sort of pressure or pain or tissue damage or whatever you want to call it in our foot. And we're walking along in the ocean. We can't see the bottom of the sand. We're just walking and walking, and all of a sudden we step on a broken bottle. Someone threw a broken beer bottle in the ocean. Right? We step on that. The instant we step on that, we pull our foot back. And then we go, ouch. We actually pull our foot back before we felt the pain. Like, really? Yeah, that fast. Okay? That receptor picked up that information. We have tissue damage, we have pain, we have pressure, whatever that case may be. Picks that up. That takes it along here into the cord. Well, what I want you to see here, that's showing you right there, the ganglion, right? There's the soma, there's a sensory arm picking it up. One cell brings it over here, and it synapses with what we call an interneuron. An interneuron. What I want you to see real quick, though, is look at this. This interneuron does not connect to the brain. There is no connection to the brain. It directly connects again with another neuron that then goes out to the effector. In other words, guess what? The brain does not control reflexes. Really? Yeah, at least not here. We have a direct connection without the brain that's involved in a reflex. This happens very, very fast. We only have 2 synapses, boom, right back to the effector, and we have a response. We pull our leg back. Right? There's a very quick response that's involved in reflexes like that. So they require stimulation, and they are quick. They are involuntary. We cannot stop them, right? And they are stereotyped. Every single time this receptor is triggered, it'll always lead to this effector. Always. This means this every single time. It's stereotyped. You cannot stop it. You cannot change it. It's the same. Now, I have to get into this situation because has anybody ever taken psychology? Couple. So you're aware of conditional responses, Pavlov's dogs, examples. Okay, I have to mention this. So what I'm talking about here in this class are somatic reflexes, meaning something that is innate or built into your body. Okay, we do have, and there are, learned reflexes, things we can learn over time. So a good example of this is Pavlov's dogs. You ever heard of this example? So what in basic experiment in psychology, at least this one, there were some other horrific ones, but this is not a horrific one. In psychology was every single time that they fed dogs, they would ring a bell. Now the dogs, when you eat, you produce saliva. It's just a normal response. So every single time for days and days and days when they fed the dogs, they ring a bell. Then one day, they didn't feed the dog, they rang the bell. Saliva came out. The dogs anticipated it. It was a learned, anticipated, stereotypical response. Okay? That's called conditioning. It's something that happens in psychology, it happens in us as well, not just dogs. That kind of thing can happen, right? But we're not talking about that here. We're talking about something that's innate or built into the body. We have these built in. Okay? So we call these somatic reflexes. Now we do have what's called visceral reflexes as well. We're going to go into that a little bit later. That's to control the visceral part of the body, the internal organs, things like that, internal responses. We're talking about here is skeletal muscles. That's somatic. Okay? We're talking about our skeletal